Assalamualaikum everyone, this is Dr. Abdurrahman here again with the very last video of this chapter, investment and refracted dyes. In this video we will discuss about the properties of investment materials that includes thermal stability, porosity and compensating expansion. Before the start of the topic, if you guys haven't subscribed to my channel, subscribe it for the update of the new videos.
So now the properties of investment materials. First of all, the thermal stability. I have divided the thermal stability in certain points. The first of it is these materials should retain their integrity at high temperatures. So, because for this purpose refractive materials are used. And secondly, they should have sufficient strength to withstand stresses set up when molten alloy enters the investment mold. When molten alloy at high temperatures casted into an investment mold, it produces stresses on the walls of the molds, so it should have sufficient strength to withstand those stresses. And now the third point, it is so important to remember that gypsum bonded investment materials decomposed above 1200 degrees centigrade. That is why gypsum bonded investment materials are not suitable for the alloys which are cast over 1200 degrees centigrade. So above 1200 degrees centigrade they decompose by interaction of silica with calcium sulfate to liberate sulfur trioxide. This whole reaction is given in this equation. It is calcium sulfate and this is sulfur dioxide, and this is the liberation of the sulfur trioxide. Due to this overall reaction, porosity is produced in the mold, and due to porosity it leads to severe weakening of the investment mold. Another reaction in gypsum bonded investment materials that is mentioned in the book occurs between calcium sulfate and carbon. So this is the equation. This is calcium sulfate and this is carbon, and this carbon is phosphate bonded materials does not require metal casting ring because they are already sufficiently hard so that they are allowed to set in plastic ring which is removed before heating. Now I am going to tell you guys which alloys can be used with the which of the investment materials. With gold alloys you use gypsum as investment materials, and precious metals, semi-precious metals and base metals alloys can be cast with the phosphate and silica bonded investment materials. Now these are the wax burnout temperatures. For gold alloys, wax burnout temperature is 700 to 750 degrees centigrade. For palladium silver alloys, it is 730 to 815 degrees centigrade, and for base metal alloys it is 815 to 900 degrees centigrade. It is important to recognize these wax burnout temperatures so that you can know that either your mold undergoes thermal expansion at these wax burnout temperatures or not. So now the burnout times need to be extended when resin based materials are used. Now the porosity. Now I'm going to teach you guys with the help of flow charts that which investment materials required vent for the escape of gases so that porosity does not occur, or which materials requires the vent for the escape of gases. First of all, the gypsum bonded and phosphate bonded materials are enoughly porous so that escape of gases can occur. As these materials are enoughly porous for the escape of gases, so they do not require any vent. In comparison to gypsum bonded and phosphate bonded materials, silica bonded materials are closely packed, so there is no escape of gases, and due to this, back pressure builds up in the mold. So this problem can be go away through the requirement of the vent so that the escape of gases can occur. Now the compensating expansion. The accuracy of fit of a casting depends primarily on the ability of the investment material to compensate for shrinkage of the alloy. What this means is shrinkage is compensated by expansion, but how? Most of the students find it difficult to understand that how is shrinkage is compensated by expansion. Now I am going to explain you guys that how shrinkage is compensated by the expansion. Now suppose you have to build a crown of 4 mm, so you have built a mold of 4 mm and then you filled it with the molten alloy, and we all know as the molten alloy when it is cooled shrinks. So here the alloy shrinks and it becomes 2 mm shorter. So to compensate this problem, what we do is we allow the mold to expand by using refractive material so they can undergo inversion expansion. Now look at this. You have to make a crown of 4 mm, so you build a mold of 4 mm. Then you allow the mold to expand on heating and it becomes 6 mm, and then you fill it with molten alloy, and now if and then on cooling alloy shrinks 2 millimeters and it becomes 4 mm, the exact measurement and fit we required. So this is the perfect technique of shrinkage is compensated by expansion. As we know, shrinkage is compensated by expansion, so it is necessary for us to all to memorize the values of shrinkage and expansions of different alloys. Gold alloys shrinkage percentage is 1.4%, nickel chromium alloys shrinks 2%, and cobalt chromium alloys shrinks 2.3%. And expansion values of certain investment materials are silica expand of about 1.6%, phosphate expands 2.0%, and gypsum bonded investment materials expands 0.3 to 1.3%. To gain this kind of expansion, you can use hygroscopic expansion to get more values of the more magnitude of the expansion.